Hello world, hello internet, and welcome to the third episode of the 2023 Nix Developer Dialogues. I am Valentin, your host. My host name is Frickler Handwerk. And if you're watching this as a recording and wonder what all of this is about, please check the first episode for some context. Since you're live, please send us all your questions on any of the channels this is being streamed to. We're streaming to YouTube, LinkedIn, Twitter, Twitch, and Owncast. And there's also a Matrix channel linked in the calendar event for this show. In the same calendar event, there's also a link to this very studio, which you can join to ask your questions in person and be part of the show. That will be absolutely amazing. Without further ado, we'll start right out with our guest today. Welcome, Robert Hensing, known as Robert H. Hi, Robert.
Hello, everyone.
Welcome to the show. Thanks so much for being here, for taking time. I'll introduce you briefly. So as many of my guests, you've been around the Nix community for many years now, and you're the founder of Hercules CI, a Nix first continuous integration service. You've been involved in recent times in Nix package architecture in the documentation team. You're part of the Nix maintainers team, and we will have shows dedicated to each of these topics later, to which, of course, you're warmly invited. But today we will talk about the module system. Apparently, it's such an important part of the ecosystem that it deserves a definite article. But before we start with that, maybe you can introduce a little bit about yourself by asking my first and obvious question: who or what got you into Nix, and why do you still stick around?
Oh, that's a great question. Yeah, so I was kind of distro hopping, I guess, in like around 2016, and yeah, I got frustrated with NixOS. I was using that at the time. It's like one of these VM-based things for like security, but it kind of got in the way. And then I figured, well, I gotta try something a bit more efficient, but it's got to be interesting. And then I sort of vaguely remembered that in uni, one of the lecturers he used a purely functional distribution. And I think maybe I was reminded through Hacker News or something. But yeah, I got started around that time. And like probably a couple months later, I used it at work to put out a fire. We had a project that was going off the rails because we didn't have a way to deploy it. And then I botched something together with Nix, and that actually it kind of saved the day. I've basically hooked ever since.
Is Nix addictive?
It is. Yes. Hi, I'm Robert. I have a Nix problem.
So you're here as the module system expert today, and so for people not familiar with the module system, probably many NixOS users have heard about modules, and they usually call them NixOS modules. But what is the module system anyway, and where does it come from?
Right. Yeah. It does originate from NixOS, but it is kind of its own component in a way. So when you write a configuration.nix, the NixOS config file, it's actually it's a module in the Nix language. It's a function in the Nix language, I meant to say, and that's because it's a module. So a module is basically it's a function that takes as its input the configuration, and as its return value, it's generally this attribute set, right, with a whole bunch of stuff in it, and that's like the part of the configuration that it contributes. So
wait, but if you say it is part of the configuration, how is it supposed to take the configuration itself?
Yeah, that's like the magic, right? And Nix is a lazy language, and that means that you can pull off some tricks with recursion. It's called explicit recursion, where you have the ability to pass the return value of a function back to the function itself. Like the simplest function that does this is called fix. And like recently we documented that one with the documentation team as well. Because it's like a very alien concept if you're used to like normal strict, non-lazy programming languages. But yeah, that's the thing you can do. And yeah, so the module systems like addition to this concept is that it actually takes care of like all the merging and some other aspects of the configuration system, like documentation, yeah, and stuff like imports, right? You can include some other files with it as well. So yeah, that all those things taken together make up the module system.
Okay, maybe very briefly on this technical detail. What's this merging about?
Right. So in a configuration like that, generally you don't think of it as it being modular, because often a configuration is just like, oh, it's this file that gets passed to a program, and stuff happens in the way that's specified in the file. But when you're dealing with something on the scale of an operating system, you have like a ton of configuration that goes into a ton of programs, and that sort of all builds up, and you can start making abstractions that makes it easier to use those things together. And so in such a context, a configuration system isn't just like a little config file parser anymore. It starts to become its own thing. And that's why you have like configuration languages with a bunch of actual general purpose programming capabilities. Yeah, that's what Nix provides. And so the module system it's basically a library for Nix that provides a bit more high level concepts that Nix itself doesn't.
So one of them being merging and the other, or are the other?
Yeah, so merging and like the whole syntax for these modules, because you can write them as a function, but if you don't have any logic or any fancy stuff going on, you can just pass an attribute set instead. Yeah, so there's a little bit of complexity there that is mostly complexity on the side of the module system, right? It just makes it easier to use.
Okay, so can one imagine the module system being a language within a language?
Yeah, that's absolutely correct. Yeah, you could call it an embedded domain-specific language, although it's not that domain-specific, unless you call like general configuration a domain, which like I don't know, maybe it is.
So where does it come from? Who invented it, and was it only for the purpose of NixOS?
Right. Yeah, I wasn't around back then. But yeah, it was like initially it was written for NixOS. I do think it's always been a separate component. Like I think the original author of the module system itself is MVP. Not sure exactly his name. Nicolas, I think, French guy. He works for Mozilla now, I believe, for a long time already. He's worked on like SpiderMonkey. Anyway, I think he basically he wrote it, but there's been contributions from many people, including like Elko and like the old guard that like worked on NixOS originally. Yeah, and since I think about 2018, if I recall correctly, Sylvan has done some work on it as well. That's around the time of the RFC 42, which is settings, where you can have these attribute sets, or that's basically dictionaries, right? That can contain arbitrary configuration, which is then translated into formats like YAML, JSON, whatever, in like a generic manner. That wasn't a thing before that time. So that's something still from that, and that's also the time that I got involved with the module system, because I noticed that he was like contributing and he didn't get any reviews. And yeah, I wanted to help out, and I started reviewing his stuff with like basically no prior knowledge of the module system, which was quite a challenge. But I'm really glad that I did, because it's a really interesting project, and I think it delivers a ton of value. And yeah, basically together we kind of made the whole RFC work, I guess. I wasn't that involved with the RFC itself, but yeah, I think I did like almost all of the reviews for it.
I remember being around at the time, and I also dug slightly into the module system code, but it's a very dark corner of the ecosystem, right?
Yeah, I mean, it's right there. You can find it, but it's a very abstract piece of machinery, right? It talks about like options and definitions and declarations and values and merging and types, and like if you're not prepared for it, you're just confused, right? Because like how do these concepts even relate? And yeah, it's a very a pretty unique kind of thing, I would think. Yeah.
What about this types concept in the module system? Is it like the type system the Nix language was always lacking?
Kinda, but it's. I think those should be different things though, because the module system, it's still a library. Like so the thing with Nix is that Nix, it cannot ever change, basically, right? We can create additions to Nix, extend its functionality, but we cannot change it, because Nix it promises to be a language that supports reproducibility. If you start changing the language, you're gonna start changing the outcomes of the expressions, the programs that run in them, which is like not reproducible. So yeah, that's like actually very, very unfortunate, I think, because it just makes Nix hard to change, right?
Well, impossible in that sense.
Yeah, yeah, exactly. But even like additions are hard, right? Because it sets a really high bar for anything that you add, because you can have to maintain it, and if it has any bugs, there's a chance that you might have to maintain the bugs as well, if people really rely on that behavior. And we're actually seeing a bit of that in the Nix team with fetch tree and fetch kit and that kind of thing. So it's tricky, but in Nix packages we don't have that problem, because in Nix packages we have the luxury that users of Nix packages, they get to pin Nix packages. They can reference it through like the flake log file or some dependency manager, and that'll give them a specific version. And whenever they check out some revision of the project, they'll get the same version. And that makes it very, very reproducible. And people don't really have to worry as much when they maintain Nix packages about this kind of compatibility. Like you don't want to like break stuff for no reason, right? But if you do have to break stuff, you can provide a migration path and things work out. And there's not a way you can actually break the promises of Nix almost. Right.
Okay, so how does the type system play into that? Is that the thing that was missing from the Nix language, and now we have it in the module system? I mean, for a long time, the module system has been around for more than a decade, right?
So it's yes and no. So my whole rant about like compatibility, reproducibility, it has some implications, right? Because in Nix we cannot really change things. whereas in Nix packages we can. So that kind of changes the character of the type system as well, because the type system in the module system, it's allowed to evolve, whereas a type system that would be for Nix, for like Nix in general, it would not be able to evolve. So I think that
Not
that
the same
puts
way, at least.
sorry.
Not in the same way, at least.
Yeah. So that puts some constraints on it that are different between the projects. Yeah, so I would argue the different, and there's also like the very practical thing that in the module system, the types they don't really check the values, they check the definitions, which is like one of these terms that feels a bit redundant. But so a definition in the module system, it's the thing that you write in the config section. So if you're writing a module with some logic in it, generally you have options and config. So options, that's where you declare options, which just says, well, the option is here, this is the type and description. And then config, that's generally where you define config. These are very unfortunate terms. They've been borrowed from the C language. We kind of have to just deal with it, I guess, at least for now. Yeah, so these definitions, they can include things like, you might have seen make if or make force or make merge, that kind of thing. Yeah, that's really specific to the module system and not really applicable to Nix code in general. So it could be a source of inspiration for a true native Nix type system. And you can use it to check types in general in Nix. But I wouldn't call it just like, oh, it's the type system, because frankly, it's not.
But it's still a very widely used component. So you said it's a library, it can be reused in other contexts than NixOS. Which other projects are using the module system?
Yeah, there's a lot of them. So obviously NixOS, but then there's Nix Darwin, which is kind of like a NixOS for macOS. It doesn't do the whole thing because obviously there's already an operating system there. But yeah, you can figure a ton of stuff on macOS with Nix Darwin. There's some projects that I wrote. There's Arion, which is the module system applied to Docker Compose, and like a CLI that builds images as well, integrated together. Let's see, Flake Parts, which is the module system applied to like the Flake schema. Maybe I shouldn't be saying Flake schema because that's an overloaded term now. But yeah, it's applied to the Flake outputs, the output attributes. So you get to like reuse some packaging logic that other people write. Let's see.
There's also Home Manager, right?
Oh yeah, of course, Home Manager. Yeah. Yeah, for like user level configuration, I think you can use it. You can use it through NixOS, or you can use it standalone. Probably through Nix Darwin as well.
Mm-hmm.
Yeah, so that basically takes care of your dot files, right? Yeah.
I've also heard Dream2Nix
like
Dream2Nix also uses the module system for package configuration.
Yeah, correct. So that's like a whole other thing as well.
Yeah, we may want to talk about it later. Yeah.
Yeah. I mean, we could do it now.
or we can do it now. Yeah. So I've recently read a comment by Sylvan on some discussion around the like module system stuff that the module system is the way to write module Nix code, and we should explore it further for other applications. So what can be done with the module system apart from the stuff that's already using it?
Yeah. So we can definitely use it more for packaging, because like Dream2Nix or DRV parts. I'm not sure if DRV parts is still a thing, but it's like the module system applied to individual packages. Yeah, I think it's just called Dream2Nix now. Dream2Nix 2. Yeah, so that would be great to explore that more. I know David Davau is putting a ton of work into that. Yeah, so that's an interesting area. And the portable service layer as well. That's
What is that?
Yeah, that's an RFC that Sander van den Berg wrote, like recently, like I think a month ago, he published it. And what that's trying to achieve is a way to basically write a service definition once and deploy it to either NixOS or some other process manager, or I guess Nix Darwin, macOS.
Which
Yeah,
uses
and
launch
that's
CTL underneath, right? Launch D.
sorry.
Where Darwin uses launch D underneath, whereas NixOS
Yeah,
is on system D.
yeah, correct. So yeah, so it's system D or launch D or I think supervisor D, and there's plenty of options to choose from, I guess. sysv init, OpenRC. What else is out there?
S6.
S6, right? Yeah. So yeah, that's actually not using the module system, at least not how he wrote it. I did write a proof of concept that does use the module system. It only works on NixOS for now, but it's designed to target anything basically. Just apply the same concept to say Nix Darwin, and then that will give you launch D support.
Yeah, do you want to show some of that? Maybe take a look at the RFC. Maybe we can have a little overview. And in the meantime, I want to remind the audience, please ask any questions that you may have. We're getting quite deeply technical into the module system now, and so we may have lost one or the other if you're not as experienced with NixOS or the module system. So please post into any of the channels we're streaming to, and I'll read the question out loud. And ideally, please join the studio and ask your question in person. And when Robert finds his screen, I can put it on the stage here. You can take a look at this proposal by Sander, which is incidentally not written in the module system. So if you can talk and look at your screen at the same time, is there, I mean, why wouldn't you just use everything, the module system for everything? Are there even like other problems or drawbacks with the module system as it is like now, right now?
I would definitely use it for everything. Yeah. So as far as drawbacks, there's a little drawback with performance. Because
how little is it?
Yeah, it kind of really depends. So if you're going to apply it to all of Nix packages, that would make it a couple times slower. So like, I think a lot of people, they learn about this performance issue through NixOS, because NixOS can be kind of slow in that it takes on the order of multiple seconds to process a configuration, right? To evaluate that. And that's really a problem with NixOS more so than with the module system, because in NixOS it loads like literally all the modules. So even all the whole long tail of like niche modules that only a couple of users actually use, they're always loaded, and that's like a big part of the reason why it's slow. So module system performance, the way to think about it is it's a constant factor overhead on top of like the data model that you have. So if you were to do the same thing in plain Nix, it's probably going to be faster because there's just less stuff that needs to happen. I mean, there's no type checking, there's no merging. Of course, it's going to be faster. But yeah, so the module system, I cannot really quantify how much it adds, but I would think maybe it's one order of magnitude, something like that. And
it can be quite a bit, right?
Yeah, but it really depends where you're using it. So if you're using it in something big and sort of low level like Nix packages, that's going to be huge. But if you're using it on the other end, like the things that you actually work with day to day, which is things like NixOS configurations or some service management. So actually the things that you're working with most of the time. That's like a tiny fraction of all the evaluation that Nix has to do. So that's really the part where this overhead pays off. So I would definitely use it in like anything that builds on top of Nix packages. Whereas for Nix packages itself, it would be great to use the module system for all the packaging, but that's probably not quite realistic, at least not with the module system that we have.
Okay, so let's look into your proof of concept and Sanders RFC. What's that supposed to be like?
Yeah. So the thing is that
can you make it a bit larger? I think no one can actually read any of that.
So the issue with the way that the RFC is written is, I think, is that it uses functions. And I mean,
just functions.
Functions are great. Don't get me wrong. I'm a functional programmer, so you won't hear me complaining. But the thing with functions is that whenever you have a function in your domain logic, it creates a division between things that are arguments and things that are the return value of it. And that doesn't seem like a big deal, and most of the time it's not. But if you're writing a system that's supposed to be modular, where you have overrides, it turns into like huge complexity pretty quickly. And we see that in Nix packages, because when you have a package, generally you have override attrs, override derivations, and also just override. And these all do different things. And that's just for like supposedly simple big derivation package. And then if you're going to look at like the language integrations, you get even more methods like override Python attrs, or in Haskell there's like override cabal, but that's not even like a method, so to speak. That's just a standalone function, and then it turns into a huge mess. And with the module system, that kind of just doesn't happen, because often you don't really need it to be a function. You would only really need it to be a function if you're gonna call it more than once. That's sort of like the rule of thumb. If you don't have to call it more than once, you can probably put it in like an option, right? And then,
but now with the service layer, you may want to call something more than once if you want to have multiple instances of a service, right?
Right. Yeah, and that's why this needs to use some techniques that aren't common yet.
Okay.
Basically, they're not used at all in NixOS. Like the only thing that comes close is profiles, where you're importing modules that are defined elsewhere. So
this is not to be confused with Nix profiles, but these are profiles in NixOS modules, right?
Yeah. I think we should rename them to archetypes or something. I mean, yeah, some of them probably should be archetypes. Maybe other, I don't know. We need a better name for it, because we have like already 3 meanings for profile. I think that's a bit too much. But yeah, these are just reusable bits of configuration that are, when you import them, they're always enabled. Like,
is that the same thing as specialization?
So specializations are they're a different thing. They're like basically this collection of like variations of the same configuration. So in NixOS, you can write a specialization and like write something like specializations dot some name, and then you can put some configuration there. And the effect of that is that you get the ability to call NixOS rebuild think you pass it like dash specialization or something, and then it'll activate that specialization, and it therefore activates that configuration that's in there.
It's like namespaces for configurations within the global configuration, something like
that. Yeah, and then you can switch between them.
Yeah, so when you pile up all these concepts together, it seems like very complicated, but really they're quite well separated in terms of their concerns, right?
Yeah. We just need to like provide a map, I guess. Working on that.
And don't forget, I mean, NixOS and Nix-based are a huge software system. It's been growing over the past 20 years. It supports tens of thousands of users and lots of use cases. So there's many things to consider here.
Yeah, the goal, insofar as there's like an explicit goal, but kind of the goal is to basically model the whole open source ecosystem in a way. So it's only slightly ambitious.
Okay, so what's your proposal about?
Yeah, so instead of having more functions and like the kind of arbitrary division that they create, and like and like to actually allow things like overriding as well. I'm proposing to use the module system for this as well. And yeah, so I think we should probably just dive into it, right? So let's see. Generic Python HTTP, that's probably a good start. So
can you make it a lot larger? It's
probably
larger. Very hard to read for most.
Let's see. Like that. I should probably then change how this looks. Can you close this? Okay, let's just use this. Yeah, so the goal is to have this sort of abstraction, right, where you write a service that's not NixOS specific. So that means that your service is going to look different, right? And so, yeah, so when you write a generic service, that's going to be a module. And in this case, I've sort of packaged the Python HTTP server as a module, just as like as an example. You're not supposed to do that in practice, but like for an example, I think it's great. Yeah, so it's a module. So it declares some options, the port and the directory that it's going to serve, and then it specifies, it defines the config, which says how that's going to work. So yeah, it's built into Python, this HTTP server thing, and you pass it a flag, and then it just serves that. So far,
that is just the module that you would supply, because in the module you don't specify port and directory that you would specify somewhere else, right?
Yeah. So this is actually kind of like a function, right? Because we don't have a value for the port and we don't have a value for the directory. Well, I guess the port has a default. But in order for this to work, you really need a directory. So if you were to evaluate just this module, you would be able to get a value from port, but you would not be able to get a value from directory, because that would just throw an exception. Yeah, so same thing with process, you would be able to get that out, but you would not be able to evaluate the arguments for it. So yeah, this is incomplete, and that's kind of what a function is, right? The function body is an incomplete expression that still needs some values. So that's kind of the correspondence, so to speak, between modules and functions. So yeah, that's definitely a valid way to think about it. Yeah, so you can think of this module as a function from HTTP server configuration to general process manager configuration. Yeah, so that's like the main example, really. And now as for how to use it, this is a NixOS test. Oh, NixOS tests are also managed through the module system nowadays. Let's see. Yeah, so it's a really simple test. It just checks that the port is opened. But what really matters is this configuration.nix. So that's the NixOS configuration that we're testing. So let's open that instead. And here you can see that in here we're importing the generic definition and providing the directory to serve. So these two things together make a complete, valid, but still abstract service.
Nice. This one serves the Nix manual.
Yeah, we need more of that, right? You do have to like browse into like /share/document, whatever. Who cares?
You could change it, right?
Yeah. You can just
fix it up right now. Let's fix it up right now. Here's my code.
You can just put a plus here and then /share and whatever. Yeah, you can do that. Right. So this is how you use it. And because this is a NixOS configuration and like NixOS like supports this in my PR, there's like a set of submodules here. It's called services.abstract. It needs a better name, but that's what it's called for now. And it's an attribute set of submodules. I think many people are familiar with submodules. They're basically the structure of the configuration system, right, where you declare the options. So it's address-off is like a dictionary, whereas a submodule is more like a class in an object-oriented programming language, or a record in Haskell. So where you have like specific fields. Who wrote all this text? Yeah, so in NixOS, it merges into this module the specifics of systemd. So technically, in the HTTP server, it would be able to figure out that it's going to run in a systemd environment, but it chooses not to. And NixOS provides this systemd stuff, so that's systemd.services. This is not the system option, because this is actually, we have the exact same option name in NixOS, right? But this is local to where is it? Local to this thing. So systemd stuff gets merged into this, and then
because abstract is a submodule itself.
Yeah.
And systemd is part of that submodule. Your systemd implementation.
Yeah, so it's like hardly an implementation even, because it just says, well, this is an attribute set of like modules that are not evaluated yet. So this is it's kind of like it just doesn't do anything basically. It just passes it along, and then at like the NixOS level, we have a little bit of logic that says, this says we're merging the systemd thing that I just showed. We're merging that into the services.abstract tree. And then what it also does
Second half of the magic.
Yeah. It basically just moves all those modules from abstract to the system services. So this is a bit of processing to add a prefix. Yeah, that's kind of all there is to it. I'm not going to say that it's super simple, but it gets the job done. And it's like all module system based, which gives you documentation. It gives you a whole lot of flexibility when it comes to modularity. Yeah, I think this is the way to do it.
Nice. But it does, I mean, it does sound, although it is fairly limited in scope and size of implementation, it does sound magical. And the module system, from what what I hear generally does feel magical to people and is not generally very well understood on the internal side. What can we do about that? So as far as I can tell, the documentation is not very great, and I'm leading the documentation team. I know that we barely have the resources to actually tackle all of the issues that we have with documentation. What can we do to make the module system more approachable and even more reusable?
Yeah, that's a great question. I think we just need to make a bit more progress with documentation, and I feel like I'm to blame for that because I've made a start with it, but I haven't been able to spend much time on actually completing that work in like recent months. So there's definitely something that I could do.
But what could others do? I mean, there's only
Yeah.
a handful of people who are so knowledgeable that they can just like blurt that out, but there's so many people who may be interested in contributing.
Yeah, I think you could just play around with it. But like maybe play around with the portable service layer thing, or just try to write your own module system application. There's still plenty of tools and file formats out there that haven't been through the module system treatment yet. And I think it's a lot of fun to do. And you sort of get a feel for it that way. Yeah.
Okay, you said so there are some limitations to the module system, such as performance, and that there is a possibility, or at least an idea, of how to make that the type system aspect of it, or maybe even the modular system aspect, a part of the Nix language proper. You've written a proposal about a year ago called Minimod. What is that? Is that supposed to be solving some of those problems?
Yeah, like maybe. So that was a result of participating in the discussions of the Nix package architecture team. So when the team started, we were looking at like what are the ways in which we could consider improving Nix packages, and one of them is making make derivation nicer. Because right now it's this huge function which has a lot of logic in it, some of which is like quite specific to only a few use cases. Like there's some logic specifically for Meson in it. That doesn't feel right. And if we could use something like the module system in Nix packages, that would help a lot with reducing the complexity of like the very core of the system, and also like having modules for things like Meson and also other build systems would just help a lot, I think, with making these integrations easier to understand, because you're getting rid of this layering that gets in the way with overriding. Really reduces the complexity of that, and you just get to write more reusable logic, and I feel that would definitely be a good thing. So there's a lot of repetition, duplication out there, and probably even more significant, there's things that we're just not doing. Like at some point, I helped with providing a package set of PKG config packages. Right, that's this. It's like half of a package manager. It only helps with like providing metadata for packages that have already been installed, and that allows you to basically build C and C++ projects, or basically projects with native dependencies. And so all these they call them modules. all these, let's just call them packages instead. All these packages have their own metadata and their own name. It's like a separate namespace that's distinct from the names that we use in Nix packages. And it would be nice to be able to say, well, I just want this pkg config package from Nix packages, and it just works.
But that's not the case yet.
It's slowly getting there. We have a small-ish package set now where the at least the frequently used ones are already there. But one of the things that we wanted to do is make sure that we have this metadata at evaluation time and also check that it's correct. So that's a little bit of logic. It's not too complicated, but it's not something that you would want to add to make derivation because it's already huge. So we don't really have a place to put this logic for doing that. So for now, you have to, I think, write 10 lines of code to make it work, to declare that it has a package config module, to add it to the set, to test that it's a valid module and that it's actually there. And it's just repetitive. And yeah, you kind of don't want to burden people with that, but for now we have to. With a modular solution, that would be easier, because then would just be one line that says, oh, this is going to do some pkg config stuff, and then another line declaring which modules to expect. And yeah, and also adding it to the package set, that's also a separate action.
Okay, how would Minimod help with that?
It's just easier to write, because now you have to declare a test, and you have to go into meta, and it probably I think it would halve the amount of syntax, and all that syntax, it's just a barrier to users who only care about their package, right? They don't want to be Nix packages experts. They just want to package something.
Right. So about getting the module system closer to the Nix language. So Elko wrote a couple of years ago now this now famous gist about Nix language changes, which proposes a new configuration syntax for the language. Is that essentially the module system baked into the language?
Yeah, I think it pretty much is.
Can we take a look at it? Do you have it handy?
I have it in a tab here. Yeah, I'll share on my screen.
Here.
I think it's this one.
You have to make it louder again.
Yeah.
Mm-hmm.
Yeah, so it starts with a couple of reasons.
Yeah, essentially the ones you named, right? So that there's a lot of complexity on top of just.
Yeah, so the overriding situation, we can flatten that with something like modules, whether that's modules or built-in module-like functionality. It's going to achieve the same thing. When I read this earlier today, I think this was not quite valid, but that's okay. It pertains to how we're currently doing these things. Yeah, so plenty of reasons, and what it proposes is some new syntax. And so this is kind of like an attribute set, like what you would do with the curly braces, but then it also has some more functionality in it. I think some vertical bars, and then you can add some declarations, I guess, for documentation or types or that kind of thing. And yeah, so this would be handled by Nix itself. So it wouldn't need to do Nix evaluation to use these declarations. Rather, it would be something that's handled by Nix itself, which is C++. So any logic that's moved from the Nix language to the C++ implementation is just going to be a lot faster. So that solves one part of the performance problem. think the other part of the performance problem is that when you're doing things in the Nix language, they tend to create a lot of values that stick around in memory. And yeah, it's somewhat possible to avoid that, but you have to like really design your library or whatever it is around that, and that's just not what people do. And I don't think we can expect people to write their code that way.
But do you think it's a good idea, because you said that if you embed the module system in the language, then you're stuck with it?
Yeah, so I feel like it's almost a good idea. It needs a bit more time. I think we should explore the module system just a bit more, because the way that it currently works, I think it's more complicated than it needs to be. And yeah, so it would be great to look for ways to basically improve the architecture of the module system. And that, yeah, and then basically we have to sort of benchmark, well, not in the sense of performance, but we have to compare the features that are provided by both the module system as a library and whatever this is. I think he called it extensible attribute sets, but I'm not entirely sure if that covers all of the proposal that's here, because it also involves things like documentation and whatnot.
So Benoit has a question. Not sure if it was discussed before. Have you considered implementing a similar module system in other languages? For example, I'm considering implementing one in Lua to configure NeoVim. No Nix involved.
Oh, that's interesting. I think Nix is an easy sort of an easy language to do it, because it's lazy and it has a sort of a lightweight syntax. So when you add syntax on top of that, it doesn't feel as heavy. I don't know how that would work out in Lua. Maybe it's comparable. I don't know. And I think what also helps is that Nix doesn't have a type system, which, like in general, that's a bit unfortunate. But it allows you to do things like calling map attributes on an attribute set when that attribute set would have been like a class or something with fields in a type language, where each of the fields has its own type. And when you're trying to implement that yourself, it just gets in the way. You would have to turn that off. And that feels dirty. And in Nix, you don't really have to care about that, because, well,
everything's that way.
Sorry?
Everything's that way.
Yeah, I guess.
I think it's definitely a relevant question. So what can one do specifically to advance the state of the art? So we have multiple approaches here. We have multiple applications exploring possible uses of the module system. We have endeavors into exploring architectures or evolved architectures of the module system, getting closer into the Nix language. You also have alternative languages doing something similar. So can you comment on Nickel, for instance? I had the impression, I work at Tweak, but I don't know really what the state of Nickel is there. I have the impression that it's kind of the module system as a separate language. What do you think about it?
Yeah, I think it's very similar to the extensible attribute set idea that Ilko described in, well, what we just looked at. Yeah, it has a lot of similar functionality. I don't know a lot about Nickel, but I think there's probably some parity between what Ilko is proposing and what Nickel does, and probably the module system itself is a bit more capable, because it has some crazy features that you probably wouldn't think of implementing right away if you're doing this in like hard-coded or natively in the language itself. There's some crazy things like extend modules, where a module can like it sort of clone itself, so to speak, or I haven't seen that in Ilko's proposal, and I'm not sure. Maybe Nickel has evolved since I last checked, but when I checked it early on, I didn't see anything like that either.
So, okay, to reduce the confusion, I recommend to just look at the official documentation and talk to the authors. So we're apparently not really helpful here. But in general, so for Hercules CI, you essentially are re-implementing lots of functionality of Nix in Haskell. I suppose I'm trying to get something out of you here. You gain some insights in where to take the Nix ecosystem from there. What do you think is the future of, I mean, specifically the module system, but generally Nix ecosystem? Where is all of that heading, and what are possibilities where we could take this in terms of, well, modeling the entire ecosystem of open source?
That's a really broad question. So yeah, it's Hercules CI. It doesn't like really re-implement a lot of Nix. Like most of it, it's just using Nix through language bindings. So when you're using Hercules CI, you're basically still using just Nix, and I try to keep it as much like native Nix as possible, right? Because for example, when you're using flakes with Hercules CI, it's just all in the flake. You get an extra attribute that allows some customization, but it's still the Nix language. It's still just flakes. So I'm not trying to change the language or like build something crazy out of it. Yeah. So as for direction where it's heading, I think a lot is happening. One of the things I noticed that like recently there's a ton of projects that provide their own sort of entry point into Nix. Either like exposing all of it, where you can just write Nix code and do the normal Nix things, or maybe it's a bit more packaged, so to speak, where you don't really interact much with Nix, but you do get to use the packages, for instance. I think.
Yeah, I've seen a TypeScript interface to Nix.
Right. Yeah, that's a new thing. Yeah, that's probably reusing Nix packages, right? So that's like you're basically hopeless without Nix packages. That's where all the good stuff happens. So they're probably reusing a lot of that, but then providing their own layer on top of it that makes it more conform to the expectations of TypeScript developers, I suppose. Yeah, so a lot of new front ends. I also see a lot of duplication, especially I think is sort of the dev shell area. There's a lot of projects. It used to be just I don't have to say it right. Dev shell by NumType, I think the earliest project. But there's also dev end by Cachix, which takes more of a framework approach where it's a bit more packaged, right? That you can write a YAML file and not write any Nix at all. And there's, I think, Organist as well, which is a nickel front end for Nix and also focuses on development shells. So yeah, sometimes I'm a bit concerned about like the number of user interfaces that we're introducing, because none of these are interchangeable or even composable.
Well, that's one approach to experimentation, right? And so, are you suggesting that we should do more of convergence work?
I don't know. I think I don't think anyone has to like really decide that. But yeah, I think that's the right perspective on it. Like the divergent, convergent thing, where you start with a bunch of experimentation and alternatives, and then eventually that settles into a few solutions. I think it would be weird for it to be just one solution that it settles on. But yeah, probably a small number of solutions. And yeah, I think this compatibility thing is part of the reason why I wrote Flake parts as well, because that's like aggressively not trying to be a framework. Like it's the almost the most minimal thing that's just module system and Flake outputs. So its goal is really to unify every project that tries to do something on top of Flakes with the module system. And there's a good number of modules out there now that you can just import, and you define an option somewhere, define a value for it, I mean, and stuff happens, and it's I think it's really nice.
Robert, we're out of time for today. I'm sorry. We could talk for hours. I mean, we meet twice a week in the Nix maintainers meeting. Thank you very much for being here today. I'll briefly announce the next show, which will be on this Thursday, November 23rd at 10:30 UTC. Thank you, Robert, again for being here. Next time we will see Rob Garbus, the marketing team lead, and we'll talk about the NixOS hype and where to get from here. This will nicely mesh into all what we've been talking about prior. And I hope to see you again in one of the other shows, hopefully with comments and questions, or even being brief guests with the other guests that we have. And everyone, see you next time for the 2023 Nix Developer Dialogues. Bye-bye. Thank you.
Thank you.